Let's discuss question number 32 from test sets. This is from gears, so theory of machines. So two 20 degrees full depth spur gears carry 35 kilowatt. Okay, so let me draw two spur gears. Only their pitch diameters I'm just drawing. Okay, so this is center, this is center. Okay, so power transmission is 35 kilowatt. Speed is 860 rpm. Speed ratio is 2 is to 1, so obviously the speed will reduce, and that is what is given. So obviously the driving one is the smaller gear and the bigger one is the receiving gear or the driven gear. That's why the speed has reduced. Okay, so okay, and with the center distance is given as 225. So let's call this as R1 and this is R2, or the pitch dias are T1 and T2. So we can write the center distance as R1 plus R2, which is nothing but in terms of pitch diameter is T1 plus T2 by 2. This is 225. So T1 plus T2 is 450. So this is one equation, but then the speed ratios are given. So obviously R1 omega 1 is R2 omega 2, and the speed ratio is omega 1 by omega 2 is 2, so that is R2 by R1, that is nothing but T2 by D1. So T2 is 2 times T1, and I have to substitute this, I get 3D1 is 450, and therefore the T1 is 150. So T1 is 150, T2 is 300 mm. We got the diameters from this center distance and the speed ratio information. But then what is asked? Let's see what is asked. The tangential force transmitted. Well, the tangential force transmitted, let's say you are supplying power here, okay, and obviously the contact is along the pressure line and this is how it pushes. But then if you resolve this force, you'll have the tangential force and one the side kick or the side thrust. Okay, so this tangential force is Ft, and so the torque that is applied on the driving gear is this tangential force into the diameter. So so that is d1, yeah, into the radius. So d1 by 2 is the tangential force that is applied, transmitted by the pinion. So this is the transmitted, okay, Ft into d1 is the torque that is coming on the pinion. So now Ft, pinion is the smallest gear, so I have just taken the first gear and the diameter of the first gear, so Ft1 by 2. Torque we can get from the power and the speed information, because 2 pi nt by 60 is the power. Okay, so from this I can calculate. So torque will be 60 into power by 2 pi n, and that is nothing but Ft into d1 by 2. So all this information when I feed in, so let's see what I get. See, 60 power is 35 kilowatt per 3 by 2 pi, speed is 860 rpm is equal to Ft. So getting the diameters was, because it will be useful here, so 150 by 2. So 150 by 2, probably we need to write in 0.15, okay, because it's an mm. So everything we are keeping it in meters. Ft by 2. So this value, if I calculate, this comes out to be 5185 newtons. So this is the tangential force on the pinion. So this is a complete problem, first getting the diameters and then getting the torque from the power and the speed information. The torque is the tangential force into diameter. So all this pressure angle is all given to confuse you. Okay, so the answer for this is A, because what is asked is tangential force, not the total force. The total force you will get once you get the tangential force, then you can find out this net force, normal force, by using the pressure angle, because the total force into cos phi will be the tangential force. So but what is required in torque is tangential force. So 5185, answer is A. Thank you.